Thank you. Okay. Good afternoon, good evening, ladies and gentlemen. Thank you for joining us this afternoon again to talk about an important topic for us. We basically have a little introduction to who we are. We are a kind of educational charity, all volunteer work. And we want to learn from each other, share expertise, educate others in the ways we can, and so that everybody can assess and use logic to make their decisions and then decide what is best for us and then move forward. So if you have anyone who is interested to talk, they can talk in English, Sinhala or Tamil, and they are welcome. They can contact us from the email that is below. Basically, we are Sri Lankans for Sri Lankans. And our mission is really to come out of the problems our country is facing. And so it's basically a recovery mission. So we know Sri Lanka is a huge crisis because of economy. There's an economic crisis that has come across. And people are wasting so much time in queues and to get power. And I believe it's a real difficult scenario at the moment in Sri Lanka. And there's no transport, everything is delayed, machines cannot work, power cuts, no lights, etc. So power crisis has become a real problem. Now, on top of that, because of the war that's going on between Ukraine and Russia, there will be more increased the costs for fuel. So power is become a major factor that will determine our outcome as well. So our recovery really needs to rationalize public money spending and find innovative solutions to our problems. So we have to reduce wastage, increase productivity, research and innovation. I think these are the three pillars that we need to focus on in whatever the way we can, and then try to improve our country. Now, in relation to this, geothermal energy is another area that makes an important area that we need to discuss. And so hopefully we can reduce our power cuts and try to reduce at least the important costs that we go for fuels. So to do that, it's my pleasure to introduce today's speaker, Professor Deepa Singh. Now, Professor Deepa Singh is currently a research professor at the National Institute of Fundamental Studies in Sri Lanka. After successful completion of his BSc and MPhil degrees in the University of Peradeniya, he excelled in commencing a PhD in Earth Science in 1999 at the University of Reading. Since then, he has worked as a senior lecturer and postdoctoral researcher at the Open University of Sri Lanka, establishing novel geology and geophysics courses. He was also an honored visiting lecturer at the University of Kelaniya, Postgraduate Institute of Science of University of Peradeniya, Macquarie University of Sydney, Australia, and RMIT University of Melbourne, Australia, and also Geoscience Teaching Unit, University of Reading in England. He has received several exploration research grants from Southern Pacific Petroleum, Milton, Australia, and British Petroleum, and scholarships of merit from the UK and Australia, whilst also being an awardee of several President's Research Awards and publication in Sri Lanka. So he is a really good scholar who will be able to enlighten us on the subject. May I welcome Professor Deepa Singh.
Thank you, Dr. Churananda, for the invitation and for the general introduction. I'll first try to share the screen. Just please bear with me. Yes, good evening for those in Sri Lanka and good afternoon for those who are joining from the UK. Yes, those who live in Sri Lanka as well as those who are aware of the current situation in Sri Lanka, must be well aware that of the power crisis we are facing right now. Yeah, actually, I'm not going to talk about the power crisis or the reasons behind that, but instead I would like to discuss a potential solution. Of course, electricity has become a prime necessity. To minimize the greenhouse effect, we need to generate the power generation. It has to go green. The questions arises whether every renewable energy source is environmental friendly. Of course, this talk is to explore a new and extremely effective green energy source for Sri Lanka. Now, of course, this is the situation in 2019, and I guess that it has not changed much during the last couple of years. As you can see, we rely heavily on imported fossil fuel. That's for more than 50% of our electricity comes from imported fossil fuel. But we have set the goal that we need to reach 70% of our energy needs from renewable energy. To reach 70% by 2030, of course, I think it is doable, but it's very difficult task, unless, of course, we use all possible renewable energy sources. Okay, in this case, you can see the renewable hydro, it has almost reached the top, that's the limit. And this renewable others means mostly solar and wind power. In addition, to meet the energy demands, we have to use thermal oil and thermal coal. So again, these are a previous all, but the percentages have not changed much. You can see that hydroelectricity is about 60% of our renewable energy sources. That's the main renewable energy, as we all know. Now it is almost reached the limit, so we may be able to create few more megawatts, but not a huge lot. So that's where we need to look for other renewable energy. Before we go into Sri Lankan context, let's go to the world. Now, in this map, it is actually the energy trends, renewable energy trends. Yes. So as you can see, even this, what is shown in blue is the countries that have positive change in renewable. So you can see even the major oil producing countries, Middle East, even they have a very high trend to generate electricity through renewable sources. But unfortunately, Sri Lanka is in red. Still, it has a negative trend. That means the energy power generation increase is not in renewable, but mostly non-renewable sources. Okay, in line with the vision of reaching the goal of 70% of energy from sustainable energy sources in Sri Lanka, we need to explore the possibility of supplementing the electricity supply from a hitherto unexplored sources. So that is one of the sources is the geothermal energy. Okay, so what is geothermal energy? Okay, so the geothermal energy is the heat in the earth. About 30% of this heat is the remnant heat from the formation process of the earth. As you know, uh, we have all learned that the earth was very hot planet long time ago and it cooled down, but in the core of the earth still there's a heat, that is a remnant heat. In addition, of course, major part of the heat it is generated by radioactive decay and chemical reactions within the earth, so that amounts to closer to 70%. Of course, in addition, small percentage of energy reaching the earth from the sun is also contributing to the geothermal energy. Okay, this is a very simple diagram. Now, if you ask how we use the geothermal energy, I would say using geothermal energy, we use water to get geothermal heat out. The heat will generate steam or vapor of another liquid through a heat exchanger to rotate the turbine. So this is the simple schematic diagram of generating geothermal energy. Now, if you look at the world geothermal energy potential, you can see that currently in the world, the installed capacity is less than 1/15th of the potential geothermal power generation. This is only considering the non and high enthalpy geothermal potential. They don't even consider Sri Lanka as a, or many other countries where already there are geothermal plants. They are even not shown here. In this one, they only show the major geothermal regions. So these are the top 10 the top countries that use geothermal for electricity generation. So there are these USA, Indonesia, Philippines, Turkey, New Zealand. They are generating more than 1 gigawatt. I mean, uh, they have installed capacities of more than 1 gigawatt. Of course, when it comes to Iceland, of course, Iceland is they are using geothermal energy for about 90% of their energy, domestic and industrial energy needs. But they use mainly as they use directly for space and district heating. So this diagram is only showing electricity generation. Okay, there are three types of geothermal energy generation types. We call them dry steam, flash steam, and binary cycle. So these countries with geysers where steam is gushing out, they can directly use the dry steam. If not, they can get the superheated water. When the water is brought to the surface of the earth surface, they instantly become steam. So those are called flash steam. And at places where the water is not hot enough to become naturally become steam, we can use a heat exchanger to generate electricity. Those are called binary cycles or binary systems. We will discuss about this in a later stage, so I will just move to the next part. In addition to generating electricity, there are many other uses of geothermal energy. of course, in Sri Lanka, I think you have all seen at least one or two geothermal springs, and usually people go there and maybe they pay a small amount of money, 50 rupees or even 20 rupees to get in, and they just go and touch the water or take one bucket of water and have and come back. So, of course, unfortunately, these geothermal springs in Sri Lanka, they are located in hot areas, naturally hot areas. So we really don't feel like having hot showers, warm showers in those areas. So we don't enjoy hot showers there. But at least we can use them to drying agriculture products, as shown here. And there's a huge potential of developing them for tourist industry, like top class hotels where they can use for saunas and steam saunas and hot showers or pools. So this is one of the examples from Iceland. So this is a 2.1 megawatt power plant. Of course, in Iceland, the ambient temperature here shows about 4 degrees Celsius. But as you can see, they have multiple uses in addition to generating electricity. So they can use them for fish farming and snow melting and swimming pools, district heating, and so on. So let's talk about the advantages of geothermal energy. This is a clean and renewable energy. Renewable because, as you know, the amount of heat in the inside of the earth cannot be exhausted for next several centuries or maybe millennia. So we consider it as a renewable energy, and it is clean. And unlike coal, diesel, or other thermal power plants, they do not emit greenhouse gases or pollutants to the environment. And they have very little or no noise pollution. You know, in some wind farms and some other ways of generating electricity, they are quite noisy. And simply because they don't produce noise or pollutants, they can be installed in any sensitive environment such as a rainforest or in a populated city. And also they can help cut down the use of coal, oil, and reduce emissions. So they are less harmful for both living and non-living organisms. And another thing is, it's a primary energy. It's available 24/7, and it is probably the only renewable energy which is not weather dependent. As you know, solar is only available for a few hours or only on dry days and is highly fluctuating. Hydroelectricity is affected by droughts. Wind power is also available only in few months per year, and it's also very highly fluctuating. Same with wave energy. I'm not telling that they should not be used, but I'm telling that this is very stable source of energy, which is reliable and predictable. So that is because it's not intermittent. This can be used as a base load energy. Because I know even personally that when we try to connect solar power to the grid, one of the major drawbacks, or at least one of the major excuses given by the CEB, that it is fluctuating and they cannot manage the fluctuation. But geothermal is very reliable. As you can see, actually, okay, this is levelized cost of production of electricity. Geothermal comes very close to wind energy. The capital cost is little higher, but fixed variable operational and maintenance cost is almost zero because we don't use we need no fuel to run it. So it has a very low levelized cost of electricity. And also geothermal power plants only needs a small space to build the power station. As you know, hydroelectricity needs a huge area for reservoir to store water. If you consider dendro power, that also need a lot of arable land for plantation of firewood. Also, solar power depends on the area of exposure. As you know, even the theoretical value is about 1 kilowatt per square meter, and then if you consider like 20% efficiency, you need 5 square meters to generate 1 kilowatt. So that you can only increase the efficiency to a certain limit. So again, that depends on the area. And wind farms also need large unobstructed areas, and most of the time people don't want to live close to wind farms because of the humming noise. So this is again the cost. This is again showing in a different way the higher limit and the lower limit and the base case and light. And the most importantly, the power plant factor is the strongest factor or the positive point for geothermal. And also the power plant factor is the factor that it operates, how many hours it can operate out of like 24 hours a day and 365 days a year. So it is like 95% of time can be operated. And it is decentralized energy. You can have a power plant and use it to power the local area. And also geothermal reservoirs has a long life. So this is the capacity factor again. This is nuclear, this orange one is geothermal. As you can see, it is only second to the nuclear power plant. And other renewables, hydroelectricity, wind, solar, photovoltaic, solar thermal, and they all come much lower, less than 40%, whereas geothermal comes to 80 to 95%. This is actually lower case. So it is also an alternative energy to coal, oil and gas capacities. And in a country like Sri Lanka, if we can use geothermal energy, we can reduce the dependence on other countries for our energy needs, because energy is one of the most important things. And if we don't have energy, I mean, nowadays it's very visible what happens when you don't have enough energy, enough fuel or energy sources. So we have to depend on other countries for import. Now, if we can develop our own power source, we can become less dependent on these other countries. Okay, now this is a map of geothermal springs in Sri Lanka. I'm sure all of you have been to at least one or two of these. And of course, these are major ones, but there are some others we have found recently. I have listed them according to the temperature. So this Kapurali is in a remote area where there are no houses, so population. It's not a populated area, so most of the people have not been there. And then the most famous one is one of the most famous ones are the Kenya and this Madunagal or Surya Weather. And Nelum Weather has the highest, second highest temperature. It is in the middle of a tank or weather. They have built a small island in the middle of the tank, and you can see, you can go there on a ferry or small boat and see that. And then the Wahava area, which is here, Wahava Marangal area, that has about 58 degrees. Mahawaya has about 55 degrees. They are easily reachable. And the next one is the Madunagala, one of the famous ones, and that's close to Hambantota. That has about 45 degrees. And probably this one is the most famous one, Kanya at Trincomalee. That's about 41 degrees. And closer to Trincomalee, there's another one which is not very well known, called Rangiri Ulpat. It's in an ancient temple property. And in addition, there are a couple of other thermal springs. Okay, so we are actually proposing to have a binary power plant in one of those areas, because our preliminary investigations indicated that we have enough heat at a shallow depth to generate electricity economically. But nowadays, with technology, we can drill up to about 5 kilometers, but when you drill deeper, the cost goes higher. So if we can get enough heat at a shallow depth, then we can generate electricity at a lower cost. But as you know, we don't have high enthalpy geothermal fields. It's so we propose to have binary power plants like this. So in a binary power plant, you inject the water from the injection well, and it brings the hot water, and we use a heat exchanger to heat another liquid. You can use some organic liquids, organic fluids, or ammonia called kalina, and then that vapor can turn a turbine and generate electricity. One good thing about this one is that all the fluids are recycled. Nothing is released to the environment. Of course, there's a small little bit of cooling, but apart from that, the working fluid, which is the kalina or the organic fluid, is totally recycled. It is not leaked, or it's not released to the environment. Also, the water we use is also recycled. So this is very clean, and also quite a well-known technology. And this is the type of power plant we plan to I'm proposing to install. So when it comes to the local context, these are the major advantages, because we have these very hard rocks, which are metamorphic rocks. They are not like limestone or sandstone like in England. I know they are mostly sedimentary rocks, so the permeability is very high. But in Sri Lanka, rocks are high-grade metamorphic rocks, crystalline rocks. Their permeability is very low, And when we use the fractures, the water will not be wasted. It will not get lost a lot. And also, because Sri Lanka is not a volcanic region, there's no poisonous gases or fumes. Because in certain areas, for example, if you consider volcanic regions such as Philippines or New Zealand, their geothermal resources are connected with volcanic activities. So when they drill or when they get the water out, there are a lot of hydrogen sulfide and sulfur dioxide, and a lot of poisonous gases are also coming out. But in Sri Lanka, we have done the gas analysis as well, and we found no volcanic gases because they are not connected with volcanoes. And also, because of the permeability is very low, we don't need much of makeup water because we can recycle the water. And also, Sri Lanka is not a dry country, so there are a lot of water resources. So we can use these water sources to use as makeup water if we need. And also, most of the geothermal springs are located in regions where relatively underdeveloped, I would say. So we can use these geothermal springs. So if we develop these, we can develop the areas. We can increase the tourism. Also, we can probably provide employment and also provide electricity to areas where there are no electricity. And also we can, at least in a small scale, we can increase the employment and skill development. If you consider the disadvantages, these are some of the disadvantages mostly because it's new to Sri Lanka and some factors are unknown. But these are not serious cases. So in addition to generating electricity, we can use them to use steam baths and sugar processing, agriculture products, drying, and so on. And so this is sort of a timeline. We have already done some geophysical work as at the Institute of Fundamental Studies. We have done some geophysical work and we have found quite promising results. So that's why I'm proposing. So yeah, and I will stop now. And thank you. And this is what we want to achieve. 70% of green energy for total power. Thank you.
Professor Deepa, thank you very much for bringing us another very important bit of knowledge, which I never had before, but also highlighting the need for multiple sources of power for the country, and also showing the resources we have as well as the resource persons who's been working on that. So fantastic. I think it's time for discussion. And if anybody wants to raise a question, please do so. You have to unmute yourself when you're speaking, please. Thank you.
I don't know whether it's Professor or Dr. Chula. I am Emmanuel Gunratnam. I am a career banker.
Yes, Emmanuel, thank you. You can use the first name, no problem.
Yeah, and I'm ever so grateful to Professor Deepa for giving a fantastic introduction to me. Personally, I'm with all the top-notch people who are present here. And I think it was a first glimpse, and it was a fantastic glimpse that you gave. Thank you very much, Professor Deepa. It was so very informative, and it was more than good news given the present context. And gentlemen, I am very happy to inform you that there is a geothermal specialist among us all the way from Iceland. We spoke about Iceland. It was so nice to see you, Thorstein, to join us via Zoom. And I would welcome you, yes, in one way, what do you call it? In a visual way to Sri Lanka. I don't know whether you have visited Sri Lanka before. So, sorry, in a virtual way, I'm sorry, in a virtual way to Sri Lanka. And Thorsten, I would appreciate if you can greet my own countrymen and top-notch professionals in this area of power generation.
Professor Thorstein, welcome to this meeting. We are really grateful for your time and contributions, so you can certainly speak.
Yeah, thanks. I'm Thorstein from Manvit in Iceland. Firstly, thanks for allowing me to join the presentation. It's interesting to see how geothermal is a little bit like considered as an option in various areas. I was just talking to my wife about this Zoom meeting before joining, and she said immediately, well, this is a great opportunity for us to see further areas in Asia outside of Indonesia and the Philippines. So yeah, I look forward to one day visit Sri Lanka. May I ask you, how is the legislation in Sri Lanka with regards to geothermal?
Professor Deepa?
Yes, sorry. Yeah.
About the legal
Sorry,
situation.
I think I missed the question. It was not very clear. Can you repeat the question, please?
Yeah, well, I find it sometimes a little bit like a hindering for development of geothermal if the legislation in the country is not really well prepared to accept this energy source.
Yes, I think you are right in that context. Even I checked the latest documents issued by the CEB for until 2040. Even in their plans, they haven't included geothermal. They have only mentioned geothermal as a possible source, but they haven't included geothermal in their plans. So we need to initiate, and we need to push for. Even there's no tariff. Currently there's no tariff established for geothermal.
Yeah.
So, but I'm sure that it is not impossible. It's we can go for, we can push for this, and because we see that we have serious trouble with the energy or lack of it. So although there's no there are no legal problems of problem of installing, but we have to set up, or we have to start the procedure, because it is quite new to Sri Lanka, and of course it is not prohibited, or there are no legal things to stop it.
Oh yeah.
Yeah, I hope I answered the question.
Yeah. Thank you a lot. There is, I assume that in the history there have been people from Sri Lanka participating in the geothermal training program in Iceland.
Yes, in fact, two of my students have already participated in the Iceland geothermal programs. Yes. Yes.
Okay, that's great. So it's a way to bring the not only the knowledge, but the kind of like the spirit to go into this direction. Yeah.
Yes, we hope that. Yeah. we hope that in future also you will keep helping us to develop our knowledge, because as I know, Iceland is one of the pioneers in geothermal energy. So I'm sure that you are much more knowledgeable about this subject, especially the practical aspects. Yes. So your comments and help all are very welcome.
Yes,
Gentlemen, if I may say, I work for the Consulate of Iceland in Sri Lanka, and the Honorary Consul General is Consul General Sujan Vijayawardena, the grandson of the first Honorary Consul General and the son of the penultimate Consul General, Mr. Ranjit Vijayawardena. And the visit by the newly appointed Norwegian ambassador, who is stationed in New Delhi, who covers this area and the Maldives. We had the privilege of him visiting Sri Lanka on the 1st of February to hand over his credentials to His Excellency the President. And he made a brief visit, the only visit that he made other than the meeting with the President, because the time was limited. He made a visit to Nara, attached to the Ministry of Fisheries. So during the discussion, what I perceived was that the new ambassador, Ambassador Gudni Bragasan, I'm sure Thorstein, you might know him, Gudni Bragasan. He's the new ambassador. He was, yeah?
No, I don't know him personally, but yeah, I recognize the Icelandic name, though, of course.
Yes. And I would say I was so very encouraged that he was positively exposed towards Sri Lanka to begin with, which is so very essential. So that is a extremely good start. And of course, the most famous sector in Sri Lanka, which has been known to Iceland, is the fisheries sector, and in a very small way the geothermal sector. And I started my work in January 2022, this year, and where I was doing some research as to any historic links with Iceland in any area. I came across this nice document, study prepared in 2011 by Mr. Vijayatilaka, who is now attached to the Renewable the Energy Resources Authority. He has done an extensive document after his visit to UNU in Iceland. So I started taking up this with Dr. Deepa and his predecessor at the Institute of Fundamental Studies. And then I started informing people who are really well into the area of geothermal power in Iceland. So as Professor Deepa mentioned, since this is a new area for Sri Lanka, not much is known. So gentlemen, the other gentlemen who are present in this Zoom meeting, I would very humbly urge you that maybe this meeting will be the first of many meetings or discussions and email exchanges to get the process started, because IFS and some from like Mr. Vijayatilaka have done the basic research. So it's a matter of escalating it. And maybe I'm 200% sure that His Excellency, the President of Sri Lanka, will give all his blessings to this project, because as Professor Deepa rightly mentioned, the power generation is a huge factor. In fact, right now we are feeling the pinch. The meeting started soon after the power cut ended in my area. So generations will bless those who pioneer this work in Sri Lanka. And Professor Deepa, hopefully, if it gets kick-started, I would say that the people of the area where these 7 or 9 locations are existing, they are the people who should be the primary beneficiaries of the power generated out of this process. So over to you.
Thank you, Emmanuel and Professor Thornstein. And there are 2 people who raised their hands to ask questions. Can I briefly say it's fantastic that the proposal, we are not just doing a kind of a lecture and stop there. We will create the forums that's necessary. So if you can send me a link for yourself and Professor Thornstein, we'll be able to make a forum going with Professor Deepa. And there are two people who raised their hand, Professor Dharmdas and Dr. Kirthi. So Professor Dharmdas first, please.
Thank you very much. I'm Dharme joining from London. Thank you very much, Professor Subasinghe, for educating us on this subject. I have four short questions I have noted down. You may have given this in the presentation, but I just want to have some ballpark figures. So what is the total installed capacity around the globe, Professor Subasinghe, in this area?
That I have to check again my data, because just a minute.
With your vast knowledge, I just need
it's about 10 gigawatt.
10 gigawatt.
That's 10,000 megawatt. That was in 2019. Yeah, right. 2019 it is 10 gigawatt.
Okay. The other thing is, what is the typical capacity of a geothermal power station? What is the range, if you like? What is the minimum and the maximum according to the current?
Yes, usually it's 2 megawatt to about 20, even up to 100. But usually most of the power plants go from 2 to 20.
20. Thank you very much. Thank you.
Yeah. Okay. Thank you.
My third question is, what is the cost of a typical geothermal power station? If you think 2 megawatts and 20, if you can give a rough, range for these two.
We calculated, we just made some estimation in Sri Lankan context using because in Sri Lanka we don't have any geothermal power plants yet. So we had to use some information from other countries.
Yes.
It came to like using some figures from other countries. We got about 1,000 million, like that is close to 1 billion rupees. That is in Sri Lankan rupees. But that is quite generously using, not using generously, putting the values. So it came to closer to 1 billion rupees.
So this is for the 2 megawatts, and then it will go a little bit higher.
Actually, it is like this. The highest cost is the exploration cost. For example, we got a quotation recently. 2 years ago, we got a quotation to drill half a kilometer, that is 500 meters. Our government GSMB quoted for 10 million.
Yeah.
Recently, another company gave 15 million, more than 15 million for one drill hole. So this is just a 4-inch small 4-inch drill hole. So drilling cost, that is just to measure the temperature. So the exploration cost is high. So once you get all the information, actually machinery cost is not much high. So once you get the information, and if you establish first set of 2 megawatts, we can easily increase it by 2 by 2, the 2, 4, 6, 8, like that, without much extra cost except for the machinery cost. It is only the machinery cost after that.
Yeah, thank you. My last question, my overall last question is, now if we take something like PV solar, the world is installing 140 gigawatts per annum these days.
Yes, I understand.
When we come to geothermal, the total power installed is 10 gigawatts, very small. So what is the main barrier for this rapid takeoff? What is the main barrier?
Okay, the main barrier is that geothermal energy is not available everywhere. Solar power is, if you consider Sri Lanka, solar power is available every inch of Sri Lanka. So that is, it's just a matter of installing it. And any person in Sri Lanka can put the solar panel or small power station on the roof of their house. But geothermal power plant can only be installed at certain points where it is suitable. It is like hydroelectricity. You can't install hydroelectricity everywhere, but solar power is receive. I mean, we are receiving solar power in every inch of the country or surface. So that is the main reason why geothermal is less.
So it's mainly the availability and also awareness of the technology as well.
That may also be a factor. Yes. Yes.
Thank you very much. Thank you.
Thank you.
Those are my questions. I just wanted to clarify. Thank you.
Thank you, Professor Dharmadasa, for all that. And Dr. Kirthi, you are there. You wanted to ask questions.
Hi, good afternoon and good evening. Can you hear me?
Yes, we can hear.
First of all, thank you very much for initiating this discussion. It's a very good discussion, a good presentation. So that's a great thing to start the discussion. Now, I had a few questions written down, but when Professor Dharmadasa asked those questions, unfortunately, my number of questions went up. so I don't want to take over the entire discussion, but I do have several questions. Now, first thing I would like to say is, when we do any project, it doesn't matter what it is. What we have to do is to clearly understand the requirements, then create a plan, then identify the risks, and decide what sort of risk we have to take and what sort of risk we have to avoid. So, and also the total cost and how to manage the costs. All these are very important questions. Now, did I understand in question to Dr. Dharmadasa's question, did you say it's estimated cost about 1,000 billion rupees?
Yeah, like 1 billion. 1 billion rupees.
1 billion rupees.
Yes, 1 billion. 1,000 million. Yes.
Now, so in dollar terms, is that how many billions would that be?
I had to. It's very difficult to answer because dollar is moving all the time up.
Because the comparisons all over the world are done dollars.
Yeah.
So you cannot compare any other country in rupees, unfortunately.
Yeah, just like 250. That's $4 million.
$4 million. Now that confuses me like anything, because I have the information that to drill one hole would cost $5 million.
No.
Now,
I think that's.
So let me finish. Now,
Yeah, sorry.
I'm talking about reliable information which I found. So there is a contradiction here. In Sri Lanka, I don't believe we have the skills. You mentioned something like to drill a 4-inch drill hole, it would cost something like, I was trying to write it down quickly, but I lost it. 10 million rupees or something for half a kilometer.
Yes.
But could you please tell me the first question, okay? How many kilometers do you think realistically we have to drill to create a realistic functional power plant? How many kilometers?
No, we see that in our indirect results, like geophysical results, there's enough heat below like few hundred meters. So it is less than 500 meters. So less than half a kilometer.
Again, I'm surprised by that because based on the data I have, you have to drill at least 2 kilometers anywhere else in the world. So in Sri Lanka, it may be a special case. I don't know. The other thing is, I also found out that in certain countries, many of the explorations they have to be give up halfway through. So the risk of having to give up is quite high. For example, in Switzerland, I understand that when they were trying to create a geothermal power plant, after drilling, they experienced 10,000 earthquakes within 6 hours. As a result, they had to give up the whole project. So the question is, has anybody done any investigation at all? What is the risk of any earthquakes in Sri Lanka if we start doing that?
Yes, Sri Lanka, as you know, Sri Lanka is not in a earthquake zone, like, because earthquakes are normally happening in close to plate margins. I think you know what are plate margins.
Yes, so let me help you then. In Switzerland, are there any earthquakes? normally?
Normally there's not, but it is quite close
Absolutely.
because
So they never had any earthquakes. When they started drilling this hole, within 6 hours, they experienced 10,000 or 6 days or 6 hours, I can't remember. They experienced 10,000 earthquakes. So that's a very high risk. So all I'm saying is, I do not think we have done enough work to understand the scope of this work. That's all I'm saying. There are high risks. They have not even been identified. I'm glad that you are doing the work. I'm really pleased, but there's a long way to go. So if we are thinking that we can use geothermal in the short term, I don't think that's a realistic target. That's my personal view, based on a lot of experience, by the way. All right. So I do have some more questions, but I don't think it's the right place to ask at the moment. So thank you very much indeed.
No,
Okay, thank you
thank you, Dr. Kirti, for highlighting that area, which is basically comes within the feasibility study. So one of our problems in Sri Lanka has been having no enough feasibility studies before we started anything. So yes, risk benefit, yes, we need to do that. But I'm sure Professor Deepa will be able to take some lead and work on that and come back and present to you about this as well. Any other questions?
Yeah, well, Thorsteinn from Madrid in Iceland. Maybe just first to mention it is quite common that to mitigate the risk of seismic activity, drilling costs, and such things. There's quite a good feasibility process before, and this is commonly something that financial institutions like the World Bank, ADB in Asia, for example, is supporting financially to make it possible for the individual countries to be able to do things like this. And about the seismic activity you mentioned earlier, Mr. Sorry, I find it difficult to pronounce your name, Kirti. This is a well-known situation when you start to inject cold or cool down fluid into the reservoir. It is normally related to the injection of the fluids. Same, I guess, was in Switzerland. These are normally called micro seismic activities, and yeah, mostly what it can do, it can make people in these communities concerned, but I don't remember any earthquake on the magnitude that it will cause damages, for example. But yeah, but this is of course something that you need to consider in the feasibility process.
Very good.
We have this quite commonly here in Iceland, that there is like an understanding of this is the.
Yeah, thanks. Thank you for that. Professor Dharmadas has a question. I think he's raised his hand again.
Thank you. This is regarding Dr. Kirti Devendra's question about earthquakes. One example I want to give, in UK, they started to release gas trapped in the earth crust by pressurizing water into the earth crust. And that way they started to get gas, but that introduced many earthquakes around the country. So what we have to be very careful not to disturb the system. If we do that, it can create many other problems which we can't solve easily. So we have to be very careful on that situation.
Yeah, I mean, thank you for that. I mean, every such project has to have a proper risk assessment and continuous monitoring. That's very true. It's good to highlight that issue as well.
yeah, that all depends on geology, actually. I know I lived in the UK for a few years, so I know the geology of UK is mostly sedimentary rocks with a lot of porosity, and they have these gas and oil traps. So when you pump the pressurized water into a sedimentary rock, especially in a weak zone, this can produce these microseismic activities. Yes, I understand that. But in Sri Lanka, it's a high-grade metamorphic rocks, very stable, geologically very stable country. And so far, we haven't found any evidence that they will create any geological problems, because even now we are drilling and getting the groundwater out. And in some countries, when you get the groundwater, sometimes whole cities are sinking, because when the groundwater level goes down, the whole area, whole subsurface layers are going down. But it is not happening in Sri Lanka because of the different geology, and probably those also can elucidate on this one as a geologist.
Dr. Kirti has another question.
Right.
Yes.
May I ask a question now? Again, this is one of the questions I had initially, but I forgot to ask it. Of course, we have to pump cold water into the drill hole to warm it up and bring it out. Could you please give me the estimate of daily or monthly or annual usage of water for this purpose? What sort of volume of water do we require?
Okay, for 2 megawatt power plant, I have calculated that we need about 42 liters per second to get enough energy. That is, let's say 50 liters a second. But we are not keep pumping into the earth. We get it recycled, because if you are installing one, it will be a binary power plant. So in a binary power plant, we don't actually cool it down and release it to the environment. We can send it back to the structures, to the drill hole, and so the water will be recycled. So the
okay.
makeup.
So thank you very much indeed. But I do have another question in that case.
Yeah, sure.
Am I right to assume that in that case, the water we pump into the ground is not absorbed by the rocks at all? Is it a concreted, so is it for completely insulated tube, the water going through? Is that right? If not, part of the water will be absorbed by the earth. We cannot have stopped that. So in that means we must be able to estimate how much water we require on an annual basis or a monthly basis. The question is, in these dry areas in Sri Lanka, how do we ensure that water is available on a continual basis?
Yes, there are several. Probably I will let. I don't know whether Professor Thorstein wants to answer that question, but okay, let me.
Yes. Sorry, I can maybe answer this. This is depending on what kind of a binary system you plan to install. And some are using almost no water, while others are using like cooling water. But for the geothermal process, you are using water from the ground and you are pumping it back into the ground. So the external water is only for cooling purposes.
Now I'm still very confused because I'm involved with some of these issues, by the way. I do have some experience. So unless it is the water part is fully insulated from the external environment, we are talking about 500 meters down the ground. We are talking about maybe 1 or 2 kilometers down the earth. So how do we create an insulated path for water to follow through to extract heat from the ground? I'm not clear about this at the moment.
Yeah, well, just based on experience from other countries, this is just to get the water from the resource, and you will return it back to the resource again, maybe on the
So there's
outflow
an
of the resource.
assumption. That means there's an assumption that there'll be groundwater in that area to start with, and we are going to extract that groundwater. Is that correct?
No, it is not only groundwater. It is the deep source water you will be utilizing.
I think perhaps we need a bit more information in this area as well. It's not very clear to me at the moment.
Yeah,
how
yeah.
it will work.
Yeah, we'll create a forum to get that information. And I think Professor Dharandas has raised the hand again.
Yeah, this may not be straight away for this question, Professor Subasinghe, as a geologist. Recently, we heard that there were some local earthquakes in Kandy area. And also, I'm a person who listens to Sri Lankan news every day. And people suggested that this is mainly because of building high-rise buildings on hills in Kandy area. Is there any truth in it? What is your view, Professor Subasinghe?
Yeah, actually, I wouldn't call it earthquakes, but usually we call them tremors.
Tremors, yes.
Yeah. These tremors can occur, or
I mean, they are small earthquakes. They are small vibrations.
Yeah. I mean, geologically we call them tremors. Anyway, so yeah, let's call them small earthquakes. These local tremors can be triggered by several factors. Sometimes even some explosions, like when you do quarrying and mining, so do some explosions, so they can cause some tremors. And sometimes when a large reservoir such as Victoria is filled up, or when they are emptied, the pressure on the surrounding mountains or the banks can change, and that may cause small, they can push them and cause small tremors. And sometimes when there are areas with a lot of limestone or marble, marble is dissolved very easily, or limestone is dissolved very easily, and they create huge cavities underneath, under the surface. So sometimes they collapse, and then they can produce these tremors. And in addition, there are some hypotheses or theories that there's a mini plate margin, or a subplate margin is developing in the south of Sri Lanka, that is between Sri Lanka and Antarctica, south of Galle, I'd say. So that is also, that is another theory, of course. That also can produce small tremors or small earthquakes.
Yeah, thank you. I mean, my little knowledge in geology tells me that Earth crust is plates sitting on top of each other. So if we try to disturb them by pressurizing water, drilling them, changing the pressure, it can affect at the end. From a loose point, it can be a volcano or any other toxic gas emissions. That is what I learned from these activities in UK, because people were shouting at these actions not to pump pressurized water to get gas out of it, because then tremors comes up. Do you need to live with frequent tremors? So general public opposed it completely. That is my little geology knowledge. Thank you.
Thank you, sir. Yeah, usually the earth crust is quite thick. I would say, like average, we say it is about 60 kilometers thick. We are talking about 600 meters, so it's not really a big enough effect to do, like, tectonically affect the earth crust. But of course, there could be local effect. As I said, when you withdraw water, or when you pressurize water underneath, and they can affect locally and produce some tremors.
Yeah.
Of course, a lot of people living with trimmers, and if you go to Japan or many other countries, so even daily they have these small trimmers. But in Sri Lanka, we are not used to them. So even when you get a very small trimmer, people are really reporting them and talking about that. So that is another factor, of course. But yes, that's the point. I mean, some point, but we have to consider it quantitatively. Thank you. Thank you.
Thank you for that. Any other questions from the participation? Okay, I think we have had a very good discussion, Professor Deepal, and also thank you for bringing into light such an important subject area. I mean, everything has a risk benefit. Obviously, we can take this forward from here. And that is my intention of all these discussions. So I will communicate with you and then we'll take it forward again. Yeah, the main purpose is to get our country back into where it was. That's our main purpose. Thank you so much for everybody. So we'll meet again next Sunday.
Okay, thank you for inviting and thank you for participating. I should thank all of you, especially Professor Lakshman Disanayak, and of course Professor Dharmadas is also my teacher. Probably he may not remember. And our chairman, Professor Atula Sumatipala, also he's not here. He's the one who introduced me to the this group. And Dr. Chulananda who invited me, and all of you for participating in this live discussion. Thank you very much.
Thanks, Professor Deepal.
Thank you, Deepa.
Thank you very much. Good night to everybody.
Good night.